Let's take a look at a couple of distance and midpoint formula applications. First, we need to remember that the Pythagorean theorem only deals with right triangles. And so you have to have a right triangle, and it's leg squared plus leg squared equals the hypotenuse squared. This is important in our example because the hypotenuse is always the longest side. They're not going to call it the hypotenuse, but you have to know that the longest one is going to be able to go here on this side and be squared, so then it's leg squared equals hypotenuse squared. Here's an example. We have 3 points. We do not need to graph them. We need to find the length of each side of this triangle, ABC, and then verify that it's a right triangle. And so first, let's find the length of each side of the triangle. We need our distance formula. And so we're going to take the square root of and we use A and B, so we're going to use A and B here. Let's take -2 minus 2 for the x's, and then 1 minus 3. That gives us the square root of, so that all belongs underneath of there. -2 minus 2 is -4. -4 squared is 16. 1 minus 2 is -2. -2 squared is 4, plus 4. So that's the square root of 20. Remember, that can be simplified because 20 is 4 times 2, and root 4 is just 2, so we have 2 root 5. Now the length of BC for this one, we're going to take B and C, and we're going to take the square root of, take the x values, subtract them, so 2 minus 3, going to square that, and we're going to add that to 3 minus 1, those are the y values, squared. And let's go ahead and, sorry, I need my pencil back. The square root of 2 minus 3 is -1. -1 squared is 1. 3 minus 2 is 3 minus 1 here. 3 minus 1 is 2. 2 squared is 4. So plus 4. So this is the square root of 5. That can't be simplified. Lastly, we take C and A. So we're going to take point A and point C, and the square root of, take the x values, -2 minus 3, square that, plus the y values, 1 minus 1, squared. Keep making these root bars too big. And when we do that, we get the square root of -2 minus 3 is -5. -5 squared is 25. 1 minus 1 is 0. 0 squared is 0. So we get the square root of 25, which is 5. So that gives us then, if you would like to see it in a little bit more concise manner instead of with all the work, we get AB equals root 20, which is 2 root 5. BC is root 5, and CA is 5. Now, yes, you can name these any other way. Could be BA, CB, and AC. They mean the exact same thing. So we have just finished part A. Part B is verifying that the triangle is a right triangle. Now what we need to do, remember, and I'd like to write this was equal to root 20 if you recall. And it's going to be easier for us to do this next step with it as root 20 instead of 2 root 5. We want to verify that the triangle is a right triangle. So we need to know which one is the longest side. Well, 2 times root 5 is larger because it's twice that. But 5 is larger yet. You can use your calculator to verify that. So what we want is leg squared plus leg squared equals the hypotenuse squared. So let's take root 20 squared plus root 5 squared equals 5 squared. Well, root 20 times itself is 20 from what we did previously. Root 5 times root 5 is 5. And is that equal to 5 squared 25? Well, we get 25 equals 25, and we have just used the Pythagorean theorem here to show that, yes, this is a right triangle. So yes, a right triangle. Here's another application for us to try. A baseball diamond is a square. That's a key piece of information, 90 feet on a side. A shortstop is standing exactly halfway between second and third base and needs to throw the ball to home plate. How far away from home plate is he? Well, if it's a square, we can put it on the coordinate plane and put home base here at the origin, 0, 0. First base here, and that is going to be at 90 because the length is 90. Here is third base, that's also 90, and we have a diamond, that's a square. And here is second plate, and that's the point, 90, 90. This works because each side is 90, so we come out here, this is 90, come out here, that's 90. So then what's this point? It's going to be horizontal here, vertical here, giving you 90, 90. Now standing halfway between second and third is the shortstop. And he's exactly halfway, so we know that the point that he is standing at is going to be what's halfway between 0 and 90, 45. So he is standing at the point 45, 90. And now, how far away from home plate is he? Because he needs to throw it here to home plate. So we need to find that distance. That's really asking us to find the distance between 0, 0 and 45, 90. Well, we know how to find the distance is using the distance formula. So the distance is equal to the square root of 45 minus 0 squared plus 90 minus 0 squared. So that's really 45 squared plus 90 squared. 45 squared is 8100. 90 squared is 2025. Add those together and you get the square root of 10,125. Now we need to use our square root button on our calculator, and that's going to give us about 127.3 feet. And that is how far away the shortstop is from home plate. So that's it. Hope you're having a great day.